Welcome to the June 2022 CIECAST, Charged for Success, Understanding EV Trends and Their Impact. I'm Paul Berry, Executive Director for CIECA. The Collision Industry Electronic Commerce Association, or CIECA, develops and promotes electronic communication standards that allow the collision industry to be more efficient. We also provide webinars like this one to help educate both members and non-members on trends that impact systems, processes, and the exchange of data across the industry. Today's presenter is Ryan Mandell, Director of Claims Performance at Mitchell International Incorporated. In his role at Mitchell, Ryan works with insurance executives, collision repairers, and material damage leaders to provide actionable insights and consultative direction for their organizations. As we start the webinar, I want to remind you there is no verbal communication between the participants and the presenter. If you have questions during the webinar, please type them in the question panel on the webinar screen. We will answer as many questions as possible at the end of the presentation. And now, I'll turn it over to Ryan Mandell. Welcome, Ryan.
Thank you very much, Paul, and thank you everybody for taking the time out of your day to spend with me today. And I'm really excited to be here sharing some information about this topic that I think is just so absolutely critical to the future of collision repair and really the future of the automotive industry as a whole. So as Paul mentioned, my name is Ryan Mandell, Director of Claims Performance at Mitchell. I'm really privileged in the role that I have to get the opportunity to work with so many different stakeholders in our industry, whether it's on the insurance side, collision repair, OEMs, auto recyclers, really bringing a lot of our insights to the widest range possible throughout the industry so that really we can help bring about more collaboration from all these different stakeholders. So today what I'm going to talk to you about is, with electrification, there's so many different topics we could delve into, but I'm going to focus on a few specific ones. Number one, we're going to talk about what does EV adoption look like? How are we seeing that trending and what's kind of driving that? We're going to look at some data from both the US and Canada to see where that's come already and where we see that headed in the future. And then we're going to talk about what does it mean when EVs come into a collision repair facility? How are they different? Why do they need to be treated differently than just a traditional internal combustion engine vehicle? And again, we'll look at some data that kind of backs that up from a complexity side in a number of different facets of the repair process. And then finally, we'll talk about what needs to be done in order to facilitate better repairs, higher quality, proper and safe repairs to take place on these vehicles. So we'll get into all of that, and then certainly we'll leave time for questions at the end of the presentation. So I think when we think about the overall automotive industry, and we look at the past couple of years, the auto industry has struggled tremendously in terms of new vehicle sales. We look at the supply chain disruption taking place as it relates to semiconductors, which has certainly hampered the availability of new vehicles. It's put delays into the new vehicle assembly process. And what you see on the screen here are just some headlines that show you some of the struggles that some of these automakers have had, and it's really across the board. Sales overall have been down for the major automakers across the world. However, the bright spot for OEMs has been when it comes to electric vehicles. We actually have seen, when we look at 2020 and 2021, overall gross vehicle sales declined by about 15%. But during that same time period, gross volumes of electric vehicle sales grew by more than 5%. So a period of growth on a gross volume basis when the rest of the industry is kind of receding. So I think that is very telling about where the industry is going. And so again, you can see just some of the highlights here in each of these bullet points. The electric vehicles are the one area where we're seeing the most growth for automakers. You know, this Mercedes-Benz chart, I think, really typifies what we're seeing there. Overall, 10 percentage point drop when you look at Q1 2022 compared to Q1 of 2021. Little bit of growth in their higher end vehicles, or the top end luxury line, but the most growth on a percentage basis coming from those electric vehicles. You know, 19 percentage point growth in the face of a 10 percentage point overall decline. So I think this is where automakers have invested significantly. We've all seen over the years all these announcements with different OEMs announcing how they're going to be going fully electric or transitioning to a fully electrified fleet over the years. So I think this is, again, is where we're seeing that growth take place. When you look at some of the projections that have been put out there, again, people are very bullish on where electric vehicles are trending. You get different, a little bit of differences along that spectrum, but I think when we look at some of the quotes that have been put out there, Bloomberg New Energy Finance covers electric vehicles pretty significantly. If you follow their coverage, they've kind of updated their forecast as time has gone on. But when they look at global EV sales, what they're showing is that they're expecting EV sales to grow from roughly about what we saw in 2021, about 6.6 million units worldwide, to over 21 million in 2025. So we're talking about tripling of that volume, more than tripling that volume in the span of 4 years. Now, to be sure, a lot of this growth that we're seeing right now is coming from China, especially, also from some of the Scandinavian countries and the rest of Europe. However, even when you look at North America as a whole, you see when we compare 2021 to 2020, a 96% growth in terms of the full battery electric hybrid or full battery electric vehicle, and the actual plug-in hybrid vehicles as a percentage of sales. So this is really important to remember, again, as we think about these vehicles coming into our repair facilities and what that means for technicians, what that means for the repair planning process, the estimatics process, and how we underwrite these vehicles as well. We're going to talk about the complexity of EVs here very soon. I put a quote on here from the Secretary of Commerce for the United States that I think is really important for us to remember, especially as we're in the midst of this semiconductor challenge. And that quote is that EVs contain almost double the number of semiconductors as internal combustion engine vehicles. So internal combustion engine vehicles have on average about 1,000 semiconductors on a new model year vehicle. An EV has almost 2,000. So I want you to keep that in the back of your mind as we're thinking about the challenges that these vehicles face, because really I think that is indicative of the type of complexity that we're seeing and the interconnectedness of all these different systems. So where do we go from here? Where's kind of consumer preference headed in North America? Well, when you look at the United States, you see roughly about, this was based on an Ernst & Young study that was done at the beginning part of this year. And what it found is that roughly about 25 to 30% of respondents in this consumer survey said that they were very likely to be considering a fully electric or plug-in hybrid vehicle for their next vehicle purchase. Pretty significant amount of consumers considering that. When you look at Canada, though, you actually see a much greater uptick. Almost 50% of consumers are considering a fully electric or plug-in hybrid. We'll talk a little bit about why that dichotomy exists and what is kind of driving some of that consumer preference. But interesting to see that you do see this elevated level and significant growth happening in the Canadian market, especially. So what does this mean when we start looking at overall repairable claims and repairable estimates that are being written? So when we look at 2019, the last pre-COVID year, compared to 2022 year to date, what we see is in the US, every category of electrification has grown. It's increased compared to pre-COVID. We're going to look at some more differences between each of these different propulsion types, and we'll break that down as we go throughout this presentation. When you see the greatest rate of change, where you see the greatest rate of change is in those electric vehicles. So we may still be under 1% of total repairable claims coming from electric vehicles, but that's something we expect to continue to grow. You've seen that number almost double since 2019. So when you look at the overall population, definitely this depends on the market that you're in. You actually see greater growth taking place in some of these EV hotspots. California, Arizona, Nevada, Florida, and Texas, for instance, is where we see the greatest growth. However, we are starting to see even large expanses of electric vehicles starting to hit other markets that are not as typical as those traditional hotspots that we've seen. So we expect that number to continue to accelerate at probably a faster pace as we move forward into 2023. Again, interestingly enough, when you look at Canada, you see continued growth, again, in each of these electrified segments, significant growth, triple the amount of electric vehicles, fully electric vehicles as a percentage of the overall repairable car park, and almost 2% of repairable claims are designated as electric vehicles in Canada. So again, this translates very closely and correlates very closely to that consumer sentiment data that we saw from Ernst & Young. And so I think a lot of people, when they see this, at least a lot of people that I've spoken to, are surprised by the fact that EV adoption is taking place a little bit more rapidly in Canada. There's a number of reasons for that. I think number one is when you look at energy costs, you look at the cost of electricity. Certainly there are many provinces where we see lower costs of electricity on per kilowatt hour basis than what we see in the United States. Quebec, for instance, much lower than what we see even in the lowest state in the United States. So when it costs less to be able to charge these vehicles, that's certainly going to alleviate one of the hurdles for adoption of these types of vehicles. Government policies, however, have also been more widespreadly promotive of EV technology and of EV adoption. And we'll talk about charging infrastructure here in just a minute, but certainly when you look at the United States, there is pro-EV policies in place, but that actually varies significantly based on the region and the specific state that you're in. In Canada, we've seen more wholesale adoption of these government policies taking place, trying to drive more rapid adoption of fully electric vehicles over time. So when it relates to charging infrastructure, this is definitely one of the largest barriers that stands to more widespread adoption. So infrastructure has expanded significantly, but we still have a long ways to go. So just to give you an idea, so this chart on the left of your screen is showing you the increase in two different types of charging stations in the United States. The bars on the left are showing you the increase in level 2 charging stations. Level 2 means they charge on average about 25 miles of range per hour in that particular charging port. The bars on your right are showing you the direct current fast chargers. Those charge about 200 miles worth of range in 30 minutes. So significant difference there. So, but what you've seen is between 2020 and 2021, at the end of both of those years, you've seen an 18% increase in the number of charging points for level 2 chargers and a 24% increase in direct current fast chargers. In Canada, you've seen roughly about a similar increase in terms of a percentage basis for those level 2 chargers, but you've actually seen about a 38% increase in those fast chargers. And that is really the technology that I think needs to be adopted most widely. The reason for that is because that is what is going to compete directly with a fuel pump. That is something that is most analogous to filling your vehicle with gas at the station, because it's something where you're not waiting a significant amount of time. It's only 30 minutes to get roughly about that 80% charge, okay? These level 2 chargers are meant for more stationary time of that vehicle, when it's at home, when it's at a place of employment, sometime where that vehicle is parked for a significant amount of time. And so if you look at how this translates to the number of charging points or the number of charging stations per electric vehicle on the roads, you see that both the United States and Canada have a ways to go to catch up to some of the more progressive countries that have adopted EVs, namely China and Korea. When you look at China and Korea on this chart, the bar is showing you the number of electric vehicles per charging station in that country. So when you look at, for instance, the top of the chart, you look at New Zealand, that's roughly about 55 vehicles per charging point in New Zealand. When you look down at Korea, you're talking about roughly 2 electric vehicles per charging point. So a lot easier to be able to charge those vehicles more readily. And again, that's what provides more of an experience that is analogous to driving an internal combustion engine vehicle, where you can really fill that vehicle with gasoline at will. We're also seeing that one of the challenges is the fact that because these charging stations are not so widespread, it's a challenge to find them. You have to use typically an app or some sort of search engine to be able to find where these charging stations are, unless you're very familiar with them, as opposed to gas stations, which are ubiquitous around both the United States and Canada. So there's a little bit of a difference in terms of the technology that's there and kind of, I think, the cultural awareness of these charging points. But I think this is something that we're seeing more and more investment from both nations that I think is going to push this forward and bring people closer to more adoption of these vehicles. The other aspect of greater adoption is battery performance. And this is important not only from a range perspective. So on the chart on the right, you can see the average range of full battery electric vehicles and also plug-in hybrids. Plug-in hybrids, because of the fact that they do still have an internal combustion engine equipped, there's, I think, less R&D going into the growth of improving those charging capacity or those range capacities. But when you look at the battery electric vehicle, that's really where I think the lion's share of interest is being put forth. And you can see over the last 10 years or so, a dramatic increase in that average range of these vehicles. And so that reduces range anxiety, people's fear of running out of charge while they're driving their vehicle. What this also does is start to reduce as one of the biggest hurdles that also exists in terms of being able to afford one of these vehicles compared to an internal combustion engine vehicle. And so when you look at the cost structure here of both an internal combustion engine vehicle and an EV, you see that the electric motor and the battery are significant portions, primarily that battery pack. 35 to 50% of the cost of manufacture of that vehicle comes from the battery. And so as we get more efficient mining techniques, as we expand the breadth of different mining technologies throughout the world and move towards more efficient battery compositions, that's going to improve the cost effectiveness of these vehicles and improve and bring us closer to that price parity between EVs and internal combustion engine vehicles. Now, one of the things that kind of stands in our way right now is what we're seeing as it relates to metals prices. This is certainly posing a significant risk to achieving that price parity and making those batteries more cost effective. So what you see on the screen here is a few of the primary metals that are involved and really crucial for electric vehicle battery production: lithium, cobalt, nickel. This doesn't even get into some of the other metals like copper that are so essential for electric vehicles. But what we've seen is over time, battery prices have been coming down. And this is very similar to kind of consumer electronics. As the technology improves, the efficiency of manufacturing improves, you see cost effectiveness improve as well. However, in 2021, we started to see kind of flattening out of these prices. And it's being driven a lot by some of these metals prices that we're seeing throughout the world. This is really, I think, a direct impact of some of the geopolitical events that we've seen, with the Russia-Ukraine conflict. A lot of metals are mined out of that area, and so that does pose a significant risk to overall price stability across the world. Certainly, just the cost of energy is really increasing the cost of mining these materials. And so you have a lot of these mining operations fueled by petroleum, and so when petroleum costs go up, the input cost, the overhead for mining these materials goes up significantly as well. So I think this is a challenge that we're in right now. This could put that timeline out a little bit in terms of how we think about when we're going to achieve price parity. There's some estimates that say that by 2025, it'll be no more expensive to purchase a Mercedes C300 electric vehicle or a C300 internal combustion engine vehicle. I think that's probably a little aggressive. I think we're probably looking more along the end of the decade to where we're going to start seeing more of that price parity take place, in part because of what we're seeing here with this increase in metals prices, and again, some of the challenges that we're seeing around the mining industry and trying to find different sources of a lot of these metals around the world. So let's shift gears a little bit here, and I want to talk about when these vehicles actually get into the shop. So it's really important to understand that an EV is not just an electrified variant of an internal combustion engine vehicle. It really is something totally different. Even though on the surface, these vehicles may look similar, the architecture is completely different and unique. And really, these vehicles need to be treated as such. So there's a number of different ways that we can look at this. We'll just share a couple here with you today. But so you look at just the number of estimate lines. So this is based on our Mitchell Estimatics data, just the number of estimate lines that are on these different vehicle types, from all the way from ICE vehicles through mild hybrids, plug-in hybrids, and EVs. You see, this is a trend that you're going to see kind of throughout this presentation. Is the further along the spectrum of electrification you move, the more complex things get. The greater the reliability on a high voltage battery, the more complex that repair. Okay, so this is kind of our first leading indicator of what that looks like, just simply looking at the number of operations, the number of lines that are being written on these estimates. And you see 47 2/3 lines on these electric vehicle estimates. That's more than 10 additional lines compared to an internal combustion engine vehicle. So pretty significant difference there. We can attribute this to many different aspects. There's a lot of there's extra components on these vehicles. Systems are more interconnected, which is kind of one of the things that we'll look at next when we think about how these vehicles are designed. And again, they're digital architecture as opposed to a mechanical architecture. So when we look at scan data, we look at frequency of scanning and the distribution of scanning between EVs and ICE vehicles, mild hybrids, plug-in hybrids, and all of that is relatively similar. All these vehicles are getting scanned at about the same rate. They're receiving diagnostics fairly regularly, and that doesn't seem to change based on propulsion type. However, where we see the biggest difference is when we actually look at the scans themselves. What is being produced on these scan reports is quite different between these different propulsion types. And so what we see on the screen here, this is the average number of fault codes that's showing up on scans of these different vehicles. It's important to note, this is based on 2015 model year and newer vehicles only. Since about 98.5% of electric vehicles on the road are 2015 model year and newer, we use that as the best comparison here to be able to understand, create a more apples to apples comparison with the rest of the car park. So this is based on about a little over 3 million scans that have been done through Mitchell Diagnostics devices over the years since these were introduced. And again, what you see is almost over 5 additional fault codes showing up on electric vehicles when compared to internal combustion engine ones. And again, as you move down that spectrum of electrification, you see more and more fault codes taking place. So why is this happening? What does this mean? Well, what I think this shows is how interconnected all these different systems are. These EVs, again, rely on more semiconductors, as we saw with that quote from the Secretary of Commerce, more digital systems, more advanced electronics to do the same kind of tasks that were being done with mechanical components in internal combustion engine vehicles. Now, certainly that technology is advanced with traditional vehicles as well, but it's on the cutting edge with electric vehicles. And so when you have a front-end accident, the likelihood of secondary and tertiary systems being impacted across that vehicle in an electric vehicle is far greater than on a vehicle that has just a traditional internal combustion engine. Simply just the fact that these systems are so much more interconnected that front-end accident does have the potential to actually impact systems on the right rear corner of that vehicle, for instance. And so again, when we look at these, we actually see this complexity really spelled out in the scan data itself. It's also important to note that this, because of the proprietary nature of Tesla systems, no aftermarket scanner is able to scan Tesla vehicles. It actually excludes Tesla data. So really, this is just looking at legacy EV data, legacy OEM EVs compared to the rest of the industry. And so I think this shows even greater what kind of complexity is present, even when you just look at the EVs that are being produced by the legacy manufacturers. Now, when we look at the differences in construction, this can be significant as well. We look at how these vehicles are constructed compared to internal combustion engine vehicles. And so when we looked at we did a study just looking at the primary sheet metal components, the exterior components of these vehicles. So this is going to be things like hoods, fenders, door shells, quarter panels, deck lids. This is what's included in this group. Again, kind of what we've seen with other aspects of our analysis here is the further you get towards full electrification, the more complex these vehicles become. So the chart you see on your screen here is the percentage of those major components, sheet metal parts, that can be classified as a lightweight material. What does a lightweight material mean? That's something that's not mild steel. So we would classify that as high strength steel, ultra high strength steel, aluminum, composite, carbon fiber, any of these types of materials that are not mild steel. So more and more of those replacement components of those exterior sheet metal parts are being classified as that kind of material for EVs. Why is that the case? One of the big reasons is the fact that these batteries in these electric vehicles are so incredibly heavy. They have such a low energy density ratio that weight has to be offset in some way, shape, or form. And so these are going to be the vehicles that are on the leading edge of lightweighting, that are going to be seeing more lightweight components to be able to, in order to offset those extremely heavy high voltage batteries. And so you see differences even within a platform, even when you look at an automaker. And so I just put one example up here for you on the screen. When you look at the 2018 Audi A3 and compare it to the 2018 Audi A3 e-tron, which is Audi's plug-in variant, you see when you look at those schematics, they look very, very similar. There's a few differences in terms of the bracketry and some of the mounting, but overall, those are the same panels, except when you look at the construction. The Audi A3 gas engine has a mild steel fender. The e-tron plug-in has an aluminum one. So this is important for us to remember, because when these vehicles are involved in an accident, these two vehicles right there, even though they may look the same, even though those fenders are designed almost identically except for the material type, they're going to respond differently in an accident because of the materials that are chosen. And so really what this means is that this creates different decision-making processes when this vehicle is in a shop. Aluminum versus steel is going to be a different decision-making process in terms of whether you're going to repair or replace that. Also, it's going to mean different types of tooling and equipment that are going to be required potentially for this kind of a repair. So what does this all mean? Like, how does this kind of come together? When we look at increased complexity, we talk about changes in the construction of these vehicles. Well, kind of where the rubber meets the road, so to speak, is when we look at cycle times. And we see significantly higher cycle times for EVs compared to the other propulsion types. And again, moving along that spectrum of electrification, you see more and more greater cycle time as we go along. Well, one of the things that we didn't see on your screen here was the additional precautions that need to be taken as it relates to that high voltage battery. Not only to make sure that we're not damaging the battery itself, but more importantly, to make sure that we're keeping everybody safe, both employees in the collision repair facility and also the vehicle owner and their family. To make sure that anybody that's coming in contact with that EV and with the battery specifically is kept safe during that process. There's a lot of energy running through these vehicles, and it's so exciting to see all of the education and all of the tools that are available now to help people understand the right way to go about repairing these vehicles and understanding the precautions that need to take place first before even getting into a basic teardown. And so that's really important. That's adding additional labor time to these estimates, to what has to happen in terms of repairing these vehicles. One example, if we just look back at that Audi A3, when you look at the plug-in version in the e-tron, Audi actually specifies that battery cannot be subjected to the temperatures inside of the paint booth because it's just too hot. And so that battery has to be removed and isolated. Well, that's about an additional 2 labor hours, 2 mechanical labor hours that need to take place. So that in and of itself is creating additional time in the process. So what does this mean for how we handle these repairs, how we in the collision repair industry or on the auto insurance side, how do we work around these? I think one of the biggest opportunities we have is to set the appropriate expectations for the consumer, for the vehicle owner. We typically think about, I think the industry standard is roughly, someone deals with a collision repair as a consumer once every about 7 to 8 years. Well, you think of someone who's a consumer who owns an EV and is now in a collision. Not only is this probably their first EV that they've likely owned, it's most likely, more than likely going to be the first time they've been in a collision in that EV. And so if they've been in a collision before, that's the only experience that they have to go off of. So it's really our job and our duty in the collision repair and auto insurance industries to help them understand why this vehicle is different, why the process for repairing that vehicle and providing a safe and proper repair is so different than on an internal combustion engine vehicle. So that means, I think, having a very knowledgeable discussion, a very honest discussion at the very beginning of the process to help them understand, listen, there's additional steps that need to be taken to make sure that this vehicle is repaired safely. And we understand that as a collision repair facility, we understand that as your insurance carrier, and we're here to make sure that that takes place. I think that really sets up the overall outcome to be a positive one. And I think it sets not only the expectations appropriately for the vehicle owner, but I think it also does so for those that are actually doing the repairs on the vehicle. Because that's something that is, if that's being kept top of mind throughout the entire process, then I think you end up with a really high quality result, both from a quality control perspective and from a customer experience standard as well. So when we, again, thinking about how these EVs are so different than internal combustion engine vehicles, does it make sense that we write estimates on them the exact same way that we've always done with internal combustion engine vehicles? I would argue that no, we need to evolve in terms of the way that estimatics is done with these vehicles. We can't just plug an EV into the same kind of template that we have for an internal combustion engine vehicle. It simply doesn't work. And so these are some of the things that Mitchell specifically is working on, and I think need to happen in order to make sure that the estimatic system is really built in a way that facilitates success, that facilitates that safe and proper repair, to make sure that outcome is, again, the highest quality in terms of the actual repair itself, and the highest quality in terms of that customer outcome, and is efficient as well. Trying to write an estimate on an EV within an internal combustion engine framework is really challenging. There's aspects of that vehicle that simply don't exist in the internal combustion engine world. So what does this mean? Like, how does this actually translate into real life here? Well, I think some of these things, again, the addition of EV-specific super categories. So you look at the chassis of this vehicle. This is just one example here on your screen. This is extremely different. This is night and day compared to a unibody vehicle. Okay, it's kind of what we refer to as a skateboard type of platform. And so what this means is there's different subcategories, there's different categories within this vehicle that don't exist on an internal combustion engine vehicle. For instance, the front suspension is present on both, but in an EV, you now have powertrain associated with both the front suspension and the rear suspension. You look at these vehicles that actually have quad motors, individual motors for each of the half axles. And so that is going to change the way we have to think about this when we're categorizing all these different parts and the operations that need to take place in terms of this vehicle. We can't just put it under suspension. We have to understand that this is a very different powertrain, and there's going to be powertrain components throughout this vehicle, not just in an engine and transmission. We're also adding the battery floor as a super category. This, again, very, very specific to EVs. When you think about the floor of a vehicle on an internal combustion engine vehicle, you're just thinking about that, mostly mild steel kind of part of the unibody, but it's very different now with the EV and the way that this chassis is designed. So we're also categorizing electric vehicles as their own vehicle type. Why is this important? Again, I think it's that understanding of expectations from the very outset. Understanding, why is this vehicle different? This is not just, is it a car, an SUV, a truck, or a van? No, this is a totally different type of vehicle, and we need to treat it as such. And so if that's the way that you're going into this vehicle and the way you're thinking about it from the very beginning, I think that really kind of helps guide you through the process, not only in writing the estimate, but in preparing a repair plan. In your communications with the customer, you're automatically, immediately thinking about this vehicle as something unique. Okay, creating new EV-specific templates, again, something that is designed specifically for electric vehicles, that is unique to the digital architecture of electric vehicles and some of the procedures that are unique to EVs. And then also creating these new EV qualifiers, understanding the different battery capacities based on kilowatt hours. There's different ranges that are available that are customizable when you buy one of these vehicles. The different electric motors, there's different electric motors based on the kilowatt performance on each of on the rear and on the front end. These are options that can be added with these vehicles. So really what we have here, I think, is we need to be taking a new approach to preparing an estimate on an electric vehicle. We need to, we are of the understanding, we understand that these vehicles are very different when they go into the repair facility. The things that need to be done to them are completely different. They are more complex than the standard internal combustion engine vehicle out there, and thus they need to be estimated the estimates need to be prepared in a more advanced fashion as well. And so, again, I think what we see here is an evolution of the estimating process to meet the challenges of EVs. And I think we're going to be getting to the point where we're actually being proactive about some of the technology that's going to be coming out and being able to get in front of some of this before it actually hits the market. And so I think what we're seeing is that EVs overall are becoming much more commonplace. Okay, we now see in the market, just in the United States, 84 individual EV models are available for sale. If we look at just 5 years ago, that number was about 14. We've seen a big jump in terms of the consumer availability of electric vehicles, and we're going to see the technology continue to improve as well. And a lot of these barriers are going to be broken down in terms of raising that EV adoption. If we continue to see elevated fuel prices, which we expect to see for some time now, that's also going to be another tailwind for EV adoption as well. So I really, really appreciate all of your time today. I want to just real quickly mention that any of you that are interested in understanding some of these more trends that are taking place in the industry and getting different perspectives on what's happening, we've gone to at Mitchell creating this monthly podcast where it's less about us talking and us more just listening to people throughout the industry. And again, hearing from different perspectives. We talk to folks that are on the collision repair side, auto insurance, but not only that, looking at recycled parts vendors, or hearing from automotive aftermarket investment bankers, understanding where's the money moving in the industry, where are we seeing investment take place? Because I think that can really help us understand what are the trends that are going to be next. Understanding what's going on with refinish, and that's our most recent episodes. Talking about the different technologies that are there now on the refinish side. And one of the crazy things, I always learn something from each of these conversations. So I think that's what's encouraging to me. One of the things I learned from this last conversation was the fact that we may be in a few short years on newer model year vehicles looking at different repair versus replace decisions depending on the color of the vehicle. I mean, that just blew my mind when I heard that. So, I encourage you to take a listen if you have a chance. These are each about 20 minutes long. They can be found on the Mitchell website. Also, they're available on Spotify. And again, I can't express my gratitude deeply enough for all of you spending some time with me this afternoon, this morning. And at this point, I'll thank you and just open it up for any questions from the audience.
Great. Thanks, Ryan. Great information. Stacy Phillips, CIECAST Marketing Director, has been monitoring the webinar for questions. Stacy, do we have any questions for Ryan?
Yes. Our first question is the cycle time difference due to shops learning how to repair electric vehicles, and do you anticipate it will eventually go down?
That's a really interesting question. Short answer, I would say no, actually. I think there is a bit of learning curve there when it comes to the process of repairing these vehicles. But I do believe, and I think that kind of showed up when we were looking at the number of estimate lines. I really think that these are just more complex to work on. And so I think we have to expect that we're always going to see, I think, longer cycle times for these electric vehicles. Again, just based on the complexity of the scan reports, different systems that you have to touch that maybe you wouldn't have to on an internal combustion engine vehicle. Also, again, those safety precautions, and that's really important to understand that as time goes by, we're probably not going to see dramatic improvement in that EV cycle time compared to other propulsion types. And so that's important, again, when you're setting those expectations for the vehicle owner, helping them understand this process is probably going to take longer than you think it is going to. And these are the reasons why. So I think, again, that sets up a really positive customer experience and really puts both the repair facility and the insurance carrier in a position of being kind of that consultative advisor for the vehicle owner as well.
Thank you, Ryan. Do you have an estimate, or are you aware of any statistics of when half of the on-road fleet will be electric vehicles, and therefore perhaps 50% of the claims will be EVs?
Yeah, I think that's the $1 million question, right? I think that's what everybody wants to know. There's so many different estimates out there. I think, probably the most aggressive estimates are saying that sometime in the mid 2030s, we could see half of the fleet being being electrified to the point of where it's a mix of full battery electric and plug-in hybrid. And the reason plug-in hybrids kind of get classified in that category sometimes is because their primary propulsion type is that high voltage battery. The backup is the internal combustion engine. With the mild hybrid, it's the reverse. So I think plug-in hybrids get grouped into that oftentimes. I would say that looking at 50% of the car park being fully electrified or a plug-in variant, we're probably looking at another 20 years worth of runway for that to really happen. But I think it's going to start accelerating much faster here in the coming years.
Thank you. What impact does vehicle lightweighting have on EV repair?
Yeah, and so I think that kind of gets to that slide where we looked at the lightweight materials. It really changes the way that these vehicles respond in an accident and the repairability of the vehicles as well. So, you look at the way aluminum responds compared to steel, and those are two completely different metals. Aluminum simply, it doesn't have the same kind of memory that steel does. It doesn't work harden. It becomes brittle when it's involved in an accident, so it's more likely to crack. So your likelihood of repair is going to be lower. When we look at each of the different propulsion types, we see a predictable trend. The further down the road you get to full electrification, the less and less repairs that you're seeing on these vehicles. And I think that's a direct product of lightweighting. Even when we take Tesla out of it, because Tesla is actually kind of very restrictive in terms of repair operations, even when you remove Tesla, you actually still see the same pattern. Not as dramatic when you get to full electrification, but certainly still that kind of stair step down in terms of the percentage of parts that are actually being repaired on those vehicles when it comes to major component parts.
Thank you. What are some of the factors that contribute to differing EV adoption rates in the US and Canada?
Yeah, so there's so many. I mean, energy prices is certainly one of them. And again, I think that's why you see Canada, and certainly in different parts of Canada where you have lower energy costs, in terms of the power grid, is going to drive greater adoption. The availability of charging stations and charging points is certainly a big factor. I think that's one of the reasons why you've seen more adoption in places like California, Texas, and Florida. Those are the places that have a more advanced charging network, a more developed charging infrastructure in place. So I think that's probably, in my mind, the biggest hurdle is the charging infrastructure. People need to be confident that wherever they go, they can charge their vehicle. Being able to charge it at home is great. Being able to charge it at your workplace is great as well. But knowing and having that confidence that no matter where you are, you can stop at a charging station is what's really going to bring about that rapid adoption. And as you saw kind of on that chart, looking at compared to other countries, we're just simply not there yet in either country. And it's going to take, we're kind of increasing by the thousands right now. I think in terms of number of charging points, I think we really need to get to the stage where we're talking about tens or hundreds of thousands of additional charging points throughout each country to be able to create that confidence from the consumer base and completely eliminate range anxiety. Until you do that, then I think you're still going to have that hurdle that's present for potential owners.
Okay, great. So assuming the same, our next question is, do you assume there are the same safety protocols applied to salvage handling and shipping?
Oh, absolutely. Absolutely. And I think that's probably one of the aspects that gets overlooked a little bit is in the salvage of these vehicles. And, probably this would be a time to advocate for more stringent training in terms of the handling of these vehicles on, their end of life process. Once they go to a salver, once they end up at an auto recycling facility, there's certainly, I think, tremendous revenue potential from these vehicles on the salvage side, both in terms of whole vehicle salvage as well as parts. But certainly an investment needs to be made in that training aspect and understanding, the safety of the people handling these vehicles and working around these vehicles. And that's a safe, when you look at these batteries, it all comes back to the batteries. That's where the biggest safety challenges are. These batteries are filled with a liquid electrolyte that's very, very caustic and very flammable. And so put in the wrong kind of conditions and not understanding how to properly care for it, you can end up with a very dangerous situation that not only affects that vehicle, anybody working on that vehicle, but potentially the rest of the facility as well. So certainly I think as we move forward and more of these vehicles are coming into the salvage pool, then we're going to see that necessarily become a greater focus for both the whole vehicle salvage industry as well as auto recyclers.
Thanks, Ryan. Does Mitchell have a forecast on the rate of total losses of EVs versus ICE vehicles?
Yeah, so it is significantly lower, primarily because Tesla has such a large portion of that market and ACVs are significantly higher. So we see the overall total loss frequency at about 16% for the most recent quarter. When you look at EVs, that number is roughly about half of that. And again, a lot of that is driven off the overall ACV of the vehicle is much higher than an internal combustion engine vehicle on average. So it's much more similar to kind of, I think, just newer model year vehicles. And again, these are going to be newer model year vehicles as a whole. So we do see, even when compared to newer model year internal combustion engine vehicles, their rate of total loss is lower, simply because of that divergence in terms of the actual cash value.
Great. Can you talk about any differences between EVs and vehicles with internal combustion engines when it comes to writing an estimate for collision damage?
Yeah, and I think I touched on that a little bit at the end when we looked at those kind of the different things that need to evolve in estimatics, and really a lot of it has to come down to the design of the vehicles. So how do we understand and this is kind of simple, it's really looking at how is that estimate categorized. How do we look at making it to where someone who's writing the estimate, it's easy for them to find all these different components. I remember writing estimates on hybrids, back when I worked at a collision repair facility and when hybrids were relatively new. And, it was a challenge to kind of find where the high voltage battery, operations were, because it was all just being built into this existing architecture for an internal combustion engine vehicle. So I think having those different categories broken out and identified really puts you in a position as an estimator or a repair planner to make sure that the operations that need to take place in that vehicle are actually getting entered on the estimate. That's going to increase estimate accuracy, and that's going to, again, kind of facilitate that proper and safe outcome. I think just the increase in terms of the different operations that are unique to EVs, and this all kind of has to do with the interrelatedness of their systems. I think the more that can be spelled out and the more that can be identified up front and take some of that work off of the estimator or the repair planner to have to go out and dig for that, the more that can be surfaced at the front end of the estimate, I think the more powerful that estimating platform becomes, and then the more valuable that estimate is in terms of helping you understand what needs to take place in this vehicle, what are the required operations, what are some of the OEM repair procedures that are specific to this vehicle. Knowing that up front and not having to go digging for all of that is really crucial to a successful estimate.
Thanks, Ryan. And do you have any ideas or recommendations of how the industry can keep up with these changes and learn more about what's taking place with EVs?
Yeah, I would say, this is something where there's obviously our industry has a number of different training resources. Of course, ICAR, OEM specific training information, which is great from a technical side. I would encourage folks to start even just doing some reading out there from some of these research firms that are putting out information regarding EVs. Again, Ernst & Young is a great one. Bloomberg New Energy Finance is another good one. Deloitte publishes information every year. There's also a couple of really good websites that I kind of follow just from time to time. InsideEVs.com is one where it's really focused on a lot of different numbers within electrification. It kind of gives you different perspectives of what's going on with electrification. McKinsey & Company publishes electric vehicle and mobility reports oftentimes, and then EV adoption is another website. I think it's evadoption.com or evadoption.net. I can't remember the exact ending off the top of my head, but that is another website where there's just different perspectives around where we're seeing the path towards EV adoption and some of the different technologies that are coming out. I think all of those are really good resources. And if you're involved in the industry, checking those out on a periodical basis is something that I think give you that confidence and understanding of where the market shift is taking place right now.
Thank you. Those are all the questions for now, Paul.
Well, thank you, Ryan. That was really interesting information. And, I know this is coming at us fast and is going to grow quickly. So great information, and thank you for taking time to meet with us.
Absolutely, my pleasure. Thank you so much for inviting me. It was a ton of fun, and look forward to doing it again sometime.
Great. As a reminder, this presentation has been recorded and will be available later today at CIECA.com. I'd invite you to check back to CIECA.com for a schedule of future broadcasts and to watch recordings of past webinars. Links are available under the CIECAST tab at the top of the page. CIECA has partnered with the Automotive Management Institute. Attendees of this webinar are eligible to receive credit toward a professional designation from AMI after taking a short quiz on its website. A link will be sent to all attendees. And finally, please follow CIECA's social media platforms to stay up to date on upcoming events and CIECA news. This concludes today's webinar.